Hi, my name is Robert Paul Jester. I'm a professor in psychiatry and addiction at the University of Montreal, and I'm trained as a neuroscientist. And today I'm going to present a little bit of work on sex, gender, and sexual orientation in stress research, specifically psychoneuroendocrine stress and the production of the stress hormone cortisol. So studying sex differences is extremely important because we know that men, women, and gender diverse people experience stress-related diseases in different ways. So women are more affected by mood disorders, PTSD, bipolar disorder, two somatic complaints, sleep problems, borderline personality, and autoimmune disorders. While men are more affected by substance abuse, schizophrenia, autism, antisocial personality, ADHD, Tourette's syndrome, Parkinson's disease, and premature mortality. These can be manifested in different ways within different subgroups. So specifically, when we look at the LGBT community, things can be flipped around where lesbian women are experiencing sometimes more substance abuse. So it's important to really keep in mind these differences within subgroups. Also, these conditions can change in terms of the representation in men and women. Cardiovascular disease is an excellent example of a condition that 50 years ago we didn't talk about as a killer for women. But now in Canada and other places in the Western world, more women are dying of heart disease every year. What's changed? Women are smoking more, women are engaged more in the workforce without equitable compensation of labor in the household. I would also say that sociocultural gender is a factor that is very important in affecting many of these stress-related diseases. And so when we talk about sex and gender, sex is really all the biological attributes of humans and animals, including physical features, chromosomes, gene expression, hormones, and anatomy. While gender is a socioculturally constructed concept which involves roles, behaviors, expressions, and identities of girls, boys, men, women, and gender diverse people. We have a tendency to think about sex as really very categorical, but even there, we can think of sex continuously. So for instance, sex hormones is an excellent example. There are some women who have as high levels of testosterone as men. So looking at sex hormones is a way of being able to look at sex as a continuous variable as well. Now I'm going to turn over to stress, which is really my focus of my research. Stress can be measured in multiple different ways. So we can look at environmental stressors. We can look at psychological stressors with scales, such as on a scale of 1 to 5, how stressed are you? And then of course, a biological perspective where we can look at stress hormones and different physiological parameters like immune responses. I'm going to argue that it's extremely important to look at all of these traditions when studying stress, because if you just focus on biology, it can be quite problematic and give you an incomplete perspective. When we talk about biological stress, we're really talking about the hypothalamic pituitary adrenal axis and the sympathetic adrenal medullary axis release of adrenaline. Um, and essentially, your brain detects a stressor, it releases hormones into the body. Um, these are produced on the adrenal glands on top of the kidneys. And these stress hormones actually return to the brain and modulate a lot of brain regions involved in cognition, emotional regulation, and feedback of the actual axis. So the hippocampus is a region in the brain that actually shuts down the HPA axis. So here you see in blue the SAM axis, which leads to the production of adrenaline, noradrenaline, and dopamine within seconds of experiencing a stressor. And then in green, you see the HPA axis, the hypothalamic pituitary adrenal axis, which within a couple of minutes will lead to the secretion of cortisol. And cortisol is a glucocorticoid that's essential role is to transform fat into sugar. But we know that cortisol also has immunosuppressive effects. It works in tandem with cytokines during a stress response, and will also over time lead to recalibrations of a lot of interconnected physiological systems. We can measure cortisol very easily by taking several saliva samples over the course of the day to look at circadian rhythms. We have a rise in the morning called the cortisol awakening response and low levels just before going to bed. And this is important to look at because in different conditions, we see different profiles. So in green, you see a very normal profile, but in red, we see what's typically seen in depression. So hypercortisol profiles, where there's a high level of production in the morning and levels sort of flatten out and remain high before going to bed. By contrast, what you see in blue is the profile in burnout, as well as trauma and fatigue and fibromyalgia, where we see actually very low levels. And so this is important because a lot of these conditions, especially in mental health, have a lot of symptoms that are quite similar, but their biology could be quite different, which has implications also for treatment. Another way that we can look at cortisol is simply by stressing people out. I say that I've spent most of my career stressing people out, collecting their spit. And we do this because this allows us to understand how people react to a stressor and then how they recover. And you can see here that men in general respond with a higher production of cortisol compared to women for stressors that involve challenge. However, there's some evidence to suggest that women are more affected by social rejection. So that's important. Gender is already playing a role in the nature of the stress response in relation to a stressor. We want to have a stress response. It's an adaptive process. Here is a normal profile, and then people recover. There's 4 profiles where we start to see potential dysregulation. So one is the repeated hits. If you're constantly activating these stress responses over time because you're living in a violent neighborhood or in a stressful context, this will wear out the stress response and the machinery of it. Related to this is a lack of adaptation. Some people are simply not able to habituate to novelty, and this can lead to problems. Another is a prolonged response. This is something that's seen a little bit more in aging, as well as in depression, where people are ruminating after being exposed to a stressor. And finally, as I mentioned, in the context of burnout and trauma, an inadequate response, where there's simply not enough production of stress hormones like cortisol. And this actually happens in about 20 to 25% of conditions related to stress. So burnout, fibromyalgia, chronic fatigue, post-traumatic stress disorder, and atypical depression, which I think is actually burnout. So this is important because without the questionnaires, you might say, well, look, this person's not really stressed out, but on questionnaires, they'll often report more symptoms of trauma and burnout. I'm going to switch gears to talk about a concept called allostasis, which is essentially how our body adapts to our environment and changes homeostasis in relation to the demands of the environment. And this is called allostasis, the stability through change. And when this becomes something chronic, this becomes what's known as allostatic load, a concept developed by Bruce McEwen and colleagues that speaks about the wear and tear of chronic stress in synergy with unhealthy behaviors. And what's unique about allostatic load and the allostasis concept compared to old school homeostatic theory is that the brain is really the central organ processing all of these responses that's influenced by environmental stressors, major life events, traumas, individual differences, behavioral responses that collectively are going to influence our ability to process a stressor and ultimately dysregulate some of the systems involved. And so allostatic load is defined as the wear and tear of chronic stress and unhealthy behaviors exacted on the brain and body. You can think of it as sort of the straw that breaks the camel's back. And what's unique about allostatic load as a concept is that it's not just cortisol. It's looking at central nervous system functioning, metabolism, immune functioning, cardiovascular functioning together. And so there's 2 central tenets of the allostatic load model is that it's great to be able to look at multiple biomarkers at once with an index. And 2, don't just look at clinical ranges or clinical thresholds, but also look at subclinical thresholds. And I'll explain this in a moment. A good sort of tool for the general public is to think about sumo wrestlers on a seesaw compared to kids. So these 2 little light kids going on a seesaw are not really going to wear out the machinery of the seesaw. But if you imagine 2 sumo wrestlers doing at it, these systems start to wear out and become dysregulated over time. And as I mentioned, it's really this nonlinear biphasic network of biomarkers. And cortisol is really seen as the kingpin in conjunction with immune functioning. So it's the cortisol stress response in connection as well with cytokine production that is seen as really the major players that then lead to a lot of dysregulation in interconnected systems. One really great way of thinking about this is as a domino effect. So cortisol cytokines get dysregulated, they're going to lead to changes in cellular functions. And that's going to have an effect on many of the biomarkers that are used in medicine to denote risk for cardiovascular disease and metabolic problems. And together, all of these biomarkers become dysregulated and increase the risk of morbidity and mortality. There's a lot of interest in thinking about this at a cellular level. One of my colleagues, Martin Picard, is very interested in mitochondrial functioning and cellular dysfunctions and telomeres, epigenetic dysregulation that really connects cortisol, cytokines, insulin, blood glucose levels to these very secondary outcomes, which are these biomarkers used traditionally in biomedicine. And so right now, the allostatic load model is focused a lot on primary mediators and secondary and tertiary outcomes, but there's increasing interest in really looking at the nitty gritty of cellular functioning that mediates these long-term effects. And it's important to think about this all in the perspective of time courses, that often what we're seeing with an allostatic load index is a lot of dysregulation downstream from cortisol and cytokine dysregulation that we would have seen years prior. And so the first time allostatic load was measured was in the context of successful aging, where they took 10 different biomarkers that were all in some way related to cortisol, and they looked at subclinical ranges for these biomarkers and essentially created a count-based index that represented the number of biomarkers that were dysregulated for an individual. And what they found, even in these successful agers, those that had a higher allostatic load showed over time decreases in cognitive functioning, physical functioning, increased risk of cardiovascular disease, and increased risk of all-cause mortality. I mean, they didn't follow up until 12 years afterwards, which is really impressive. And not surprising, the allostatic load index was a stronger predictor than individual biomarkers, and was found to be unique than compared to other configurations such as the metabolic syndrome or the Framingham cardiovascular model. So I think it's because of the inclusion of cortisol, and over time we've actually seen more inclusion of immune biomarkers as well. Another way that allostatic load can be measured is through clinical norms. So here you see a person's got 7 because it passes the threshold of 5.2. This person actually develops diabetes in 2 years. If you look at their glucose, not quite at 6, but 5.4 is pretty close. Triglycerides 1.51, not quite at 1.8, but quite close. So what you do is you'd use the 75th percentile for biomarkers where high levels are problematic, and then the 25th percentile for biomarkers where low levels are bad. So here you see HDL cholesterol. Good cholesterol is actually quite high, so that's fine. And so for these 4 different biomarkers, this person would have a score of 3, because out of these 4 biomarkers, there's 3 of them that would pass this threshold of risk. There's been a lot of studies over the last 30 years, and here what you see is the number of studies on the x-axis. And on the y-axis, you see all the different biomarkers that have been used. And as I mentioned, there's an increasing interest in immune and inflammatory biomarkers within the allostatic load model. And there's been a lot of cross-cultural validation. A lot of big public health studies have validated this model. And what comes out of it is increased age is the strongest predictor of allostatic load, low social economic status, non-white race ethnicities, and interactions among those. So for instance, Black women in poverty. Sex is a variable that's actually inconsistent. And of the studies that find sex differences in allostatic load, there's evidence to suggest that men have higher allostatic load than women, but women actually show more correlations with sociocultural gender factors. So here you see some different factors that are related to allostatic load. So women that attend religious services more often have lower allostatic load, but this is a finding not seen in men. Men and women benefit from social networks in different ways. So among older Taiwanese couples, men benefited much more from having a wife, and wives benefited much more from having a close group of friends. So once again, are these sex differences? I think they're more sociocultural, gender-based. And so I just want to show this as a model that's going to link up to the rest of my presentation, where it's really important to think of these phenomena along a transdisciplinary perspective and to really incorporate multiple measures in order to understand what's going on. So questionnaires, biomarkers. Here you see all the different factors that have been correlated with allostatic load, and here are all the different outcomes that have been found in relation to allostatic load. And so a great area of interest in my research program is to understand sex and gender perspectives and to try to move beyond binary sex in looking at allostatic load and stress physiology. And so my first area that I focused on was sexual orientation, which is not quite sex or gender, it's its own category, but there's a lot more gender diversity in the LGBT community. And so we know that the LGBT community experiences more stigma, more stress-related diseases, and these forms of stigma are thought to come from distal processes, so more macro level discrimination, violence, laws, and more proximal stress processes, such as the coming out process or internalized transphobia. In 2011, there was a really important report from the Institute of Medicine that put this line of research in priority. And since then, we've really seen an explosion of research in the health science field. And a lot of this has been informed by Ilan Mayer's sexual minority stress model that's also been applied to gender minorities. And the idea is having a minority status leads to minority identity and unique forms of stress processes that will influence mental health, and also unique forms of coping and social support. Um, Part of this model that has been suggested was looking at stress biomarkers. And so that was something that I wanted to develop during my PhD when working with Sonia Lupien and Jens Kusner. And at the time, there hadn't been very much research looking at stress biomarkers in the LGBTQ community. And here you see individuals that are out of the closet when they're HIV positive. Those that are out actually show greater survival over time compared to those that are still in the closet about their HIV status. Another study looked at individuals who come out of the closet at home, at work, in a study of men in Arizona. And this study actually found that those that had come out had higher levels of cortisol and more negative affect. So it's important to think about the next part of my presentation in the context of geography and developmental processes such as the coming out process. Another really cool study looked at stress reactivity and found that those individuals that grew up in states that were more stigmatizing to the LGBTQ community and had less laws in place were showing a sort of flat response in response to a stressor. And as I mentioned, this is something that we see in trauma, as well as in some of the discrimination literature. So I did a study in Canada, and while Canada has had same-sex marriage quite a bit before the US, there was still quite a bit of division when same-sex marriage was voted. And so I'm going to show you a project that was done with 87 Montrealers, half of which were gay, lesbian, or bisexual, and half were heterosexual, mean age 25. And we measured sexual orientation in diverse ways. So different advertisement responses, open-ended questions, and using continuous measures using a questionnaire. This is our protocol. This is a very standard psychoneuroendocrine profile. People come in for a visit in the morning where we do a blood draw. We give them questionnaires. They complete sampling of urine and saliva samples at home. They come back for an afternoon visit, and we expose them to a stressor. And throughout, we measure 10 different saliva samples and blood pressure recordings to look at their reactivity to the stressor and their recovery. And what you see here is their stress reactivity. And what you see here is the stressor. And it takes about 20 minutes to see an increase in cortisol when exposed to a stressor. And what you see here are that lesbian and bisexual women actually showed higher levels of cortisol 40 minutes after the stressor compared to heterosexual women. And for men, we found that gay and bisexual men actually flatlined. They didn't show any, they showed a blunt response compared to heterosexual men. So this was really the first evidence looking at sexual orientation as a modulator of stress reactivity. However, when we looked at blood pressure, we actually found that gay and bisexual men had higher heart rate throughout. So that's interesting because they had lower levels of cortisol, but they had higher levels of cardiovascular functioning. So it's important to think about all these different systems in tandem. And that's really at the heart of what the allostatic load model is trying to look at. Now for diurnal cortisol, we found no differences based on sexual orientation, but we looked at those people who'd come out of the closet or not among our LGB participants. And those that were completely out to family and friends had lower levels of cortisol compared to those that were still in the closet. In terms of mental health, we found really no evidence for a sexual minority stress model. Even gay and bisexual men showed lower levels of depression than heterosexual men, which was not a finding that we had hypothesized. But it was being driven largely by people who'd come out of the closet. So those that were out had less anxiety, less depression, and less burnout symptoms. So this is really important because this gives some perspective about the physiology and the results that we're seeing with cortisol, because this sample was actually largely based of people that had come out of the closet. Now for allostatic load, we had 20 different biomarkers in total. And what we found was that gay and bisexual men actually had lower levels of allostatic load compared to heterosexual men. And this was driven by lower body mass index, lower triglycerides, and lower levels of cytokines. So that's really interesting. What could be driving that? There's some evidence to show that gay men in general pay a little bit more attention to diet and exercise, and often as a group have a little bit more body dysmorphia than heterosexual men. Could that in some way influence their biomarker profiles? It's something that we're going to be looking at in the future. We didn't find any differences based on coming out, but we did do some secondary analysis and found that coping strategies were very important. So if you engaged in more avoidance coping during your coming out process, you had higher allostatic load. And if you engaged in more seeking social support, you had lower levels of perceived distress. So I want to point out this is a study done in Canada. Canada's got it's quite liberal. Stephen Colbert laughed about this study, saying that it would have to be done with real humans, so not Canadians. So that was part of what inspired me during my postdoc at Columbia University, working with Mark Katzenbuehler, Anke Erhardt, and Walter Bochting. One of the studies that I was part of with researchers from UCLA was to look at allostatic load in a sample of about 14,000 Americans. And we found we actually replicated our findings from Montreal. Gay men actually showed lower allostatic load than heterosexual men, but because we had enough power between subgroups, we were able to split things up, and we found that bisexual men were actually the ones with the highest allostatic load, which was really interesting. There's quite a bit of research showing that bisexuals experience more stigma from both gay and lesbian communities as well as heterosexual communities. So I think this is really important to think about subgroups. We can't just clump together LGBT. There needs to be also more representation of trans and or gender diverse people. This is a group, unfortunately, that has not been represented in a lot of studies that have biomarkers in the US, and I'm hoping that that's something that will change in the future. I just want to point out no differences were found among women, and that was kind of surprising because lesbian women in this sample actually had higher body mass index, but when looking at their lipid profiles, they actually were quite healthy. So it's these processes and these different biomarker profiles need to be studied more in the future. And I'd like to also point out that we're just looking at group differences here, but there's a lot going on in these different groups. So we've been able to show that coming out processes, whether someone's completely come out or not, has a huge influence on people's stress. Different intersections of race, ethnicity, and age, and social economics and geography are also extremely important to consider. And I think moving forward, health behavior. So looking at people's diet, looking at their physical activity, looking at whether they're smoking and drinking, these are all things that need to be looked at a subgroup level in order to understand allostatic load a little bit better. And I mentioned that transgender individuals have not been well represented. I'm going to show you some work by Zachary Dubois, which is really the first of its kind to look at stress biomarkers among trans individuals. And what this study found was that those transgender men that experience more stress with regards to transitioning, more stress with regards to coming out, and more stress with regards to public bathrooms had higher levels of cortisol than individuals that had less stress. So this is a really important work that's being followed now with larger samples throughout the US. And we're also hoping to do parallel research in Canada. And what's cool about all this work is we're expanding a lot of research that's been done in psychology and in public health. And we're really hoping that biomarker research provides a complement to a lot of this psychological and social research. And what we're finding is actually not entirely consistent with sexual minority and gender minority stress models. And that really points to, I think, different resilience processes that really need to be looked at further. So coping strategies, social supports, and community resources are extremely important to look at. So with that, I'd like to thank you very much for your attention.